Hi and welcome to this on Maths prediction for the AQA Higher Tier Maths Paper 1 GCSE. Enjoy! Hi and welcome to this prediction. So whenever I do these predictions, in the comments people always say that I waffle on too much at the start, so I'll keep this brief. Please feel free to go to onmaths.com where you can do this entire paper online for free. You can sign up for free if you choose to, and it will save your scores. On the website there are loads and loads of other resources like the Revisionator, which is quick questions to get you practicing, all with videos that show you how to do it. There's Topic Busters, which just go through all of the topics, so if you're a bit weak on simultaneous equations you can go and search for that. And there's Demon Questions, which are for the people looking for the top grades, either grade 5 on the foundation or a grade 9 on the higher, and they're kind of the AO3, the problem solving types of question. So we've got loads going on the site. There's also a few more things we're looking to add very, very shortly to help you with your revision. So just go to onmaths.com and check it out. Also, if you're watching this video and it's quite close to the exam, we do set up a sister site at onmaths.co.uk where you can also do this, the papers online. You can't log into it, it's quite bare bone, but we host it at a different server because normally we're getting tens of thousands of hits all at one time for the day before the exam. So feel free to go to that site instead if the servers are not happy. And we spend a lot of money on servers, but it's never enough when you get so much traffic at the same time. So please feel free to use that. Also, if you enjoy this video, please click like and subscribe. As soon as the paper 1 comes out, and you sit the paper 1 at the end of May or mid-May, then we'll be working on the paper 2 prediction. So please click subscribe, and as soon as our videos come up, which hopefully is very, very quick, maybe 1 or 2 days, for some of the exam boards, you'll get notified. So I hope you enjoy this video. Thank you very much. So this is a question where we're dividing indices. So whenever you divide two powers with the same base, and the base here is 11, all you do is you just need to subtract the powers. So 21 take away 14 is going to be 11 to the power of 7. Okay, so first of all, we're asked to find that to prove that they are congruent. Now, congruent means exactly the same lengths, exactly the same angles, exactly the same shape, so exactly the same thing. But you can rotate with congruency. Okay, so the proofs are side, side, side. Well, we only have 2 of the sides. Now, theoretically, we could work out the other side by using Pythagoras' theorem, but we don't actually have to do that. So you could use side, side, side by using Pythagoras, working out the third side, and then working from there. The other one is AAS, or ASA, which is angles, angle, side, angle. Now, we're only given one angle, which is the 90 degrees, so we're not going to be using that one. The other one is side, angle, side. Well, we have a side, and an angle and another side, but the problem is the angle needs to be between the sides, and here the 90 degrees isn't between those two sides, so it's not going to be that one. The last one is RHS, right angle, hypotenuse, side. So let's have a look and see if we've got that one. Well, we've got the right angle, we've got the hypotenuse, and then we've got another side. All 3 of those, obviously the right angle is the same, but all 3 of those are the same. So the right angle is there, the hypotenuse is 12 meters, and then the other side is 7 meters. So the proof that we use for this is just RHS. For these types of questions, always make sure that you show your working, show how you know something is something. So the way I would start this, and this is not the only correct answer, is I realise that these 2 are the same. So I know that 2y minus 50 equals 52. The reason I know that is that they are corresponding angles. Now, some of you might know that as F angles, but make sure you write the word corresponding because they won't accept any other word. So I can solve this by first of all adding 50 to both sides. So that's 2y equals 102, and then I'm going to halve both sides. So y equals 51. So I know y is 51, so I now know that this angle here is 51 degrees. Now I know that this is 52 degrees because if you look at this, and I'll use a different colour, this angle here and this angle here are Z angles or alternate angles, or you can say that this 52 degrees here is equal to this here, which is also 52, because they're vertically opposite angles. So I know that this one here, and I could call it a letter on the diagram, so I could say C. I don't think there's another C, so C equals 52, and show the examiner, right, that's because, well, let's go for alternate angles with the original value. Okay, so we've got three sides, or three angles in a triangle. I've got way too many colours going on here. So to work out x, so x equals, it's going to be 180 minus 51 plus 52. So work out what 51 plus 52 is, and then take away from 180. And the reason is angles in triangle. Okay, so I know that 51 plus 52 is going to be 103. Therefore that's going to be 77 degrees. So my answer is 77 degrees. Okay, first thing to realise with this question is how you calculate the mean. The mean is the sum of all the values over the amount of the values. Now this actually creates a triangle, just like speed, distance, time triangle. Works in the same way. So we have mean here, we have the sum at the top and the amount at the bottom. So we normally do the sum divided by the amount, but actually with this question we need to go the other way. And we need to work out the sum or the amount or whatever. Let's have a look. So it says there's 12 boys and 8 girls. So in total there's 20 children. So that's the first thing we need to realise. It says the mean number of coins for the children is 15. And the mean number of coins for the boys is 13, and we've got to work out the mean number of coins for the girls. So we know how many girls there are, which is 8, but we don't know the total amount of coins for the girls. For the boys. Okay, so where do we start? Well, it would be helpful to work out how much coins there are in total. So if I look at the triangle there, we know, so let's write down total children. I'm going to try and show my working out as I go. We know that the mean of all the children is 15. So in my triangle, I've got 15 for the mean. We know that there are 20 children in total, and we can work out the sum by timesing those together. So we're going to do 15 times 20. So there's 300 coins altogether. Okay, so now next we're going to work out, well, we're given the boys, so let's work out how many the boys have. So same triangle, we know the mean for the boys is 13, and we know that there are 12 boys. So we're going to do 13 times 12, which is 156. So to work out how many girls there are, or to work out the sum of the girls, we're going to do the sum of all the children, which is 300, take away the sum of the boys, which is 156. So we'll do 300 take away 156, which is 144. So we know what the girls add up to, because if the boys add up to 156 and the total children adds up to 300, then the girls must add up to 144. But we're asked for the mean for the girls. So to work out the mean, we just go back to our standard formula we had at the start, which is this one. To work out the mean, it's the sum, which we worked out as 144, over the total, and it says there's 8 girls. So we do 144 divided by 8, which equals 18. So our answer is 18. Okay, so this question is a little bit more complicated than it first seems. So we've got Adrian, Ben, and Charlie, and they share some sweets in the ratio of 6 to 3 to 8. And it says that Charlie got 12 more sweets than Adrian. Well, first of all, let's have a look and see how many more parts that Charlie... Ooh. Always cross my L's for some reason. Charlie got more than Adrian. Okay, so he got 8 take away 6 is 2. So he got 2 more parts. And so let's have a look and see what one part is worth. So those 2 parts equates to 12 more sweets. So we do 12 divided by 2, 6. So each part is worth 6 sweets. And it says work out the total amount of sweets. So we need to work out how many parts there are in total. So we do 6 plus 3 plus 8. Now I know 6 plus 8 is 14, plus 3 is 17. So we've got 17 parts in total. Each of them is worth 6 sweets. So to work out the amount of sweets, we do 17 times 6. Now we could do 7 times 6, which is 42, 10 times 6, which is 60. So add the 2 together, it's 102. So there are 102 sweets altogether. To find prime factors, the easiest method is to do it as a little tree. I'm thinking of 2 numbers that multiply together to make 75. Now there's a few choices I can make, but I know that any number that ending in 0 or 5 is in the 5 times table. And let's have a think. 5 times 10 is 50, 5 times 5 is 25, so that's going to be 15 there. Then I'm going to split that 15 up. That 5 is a prime number, so we can stop there. So 15 is 3 times 5. Now both 3 and 5 are prime numbers, so we stop there. Now it says it wants it in index form, so we're going to start off with 3, but there's no other 3's there, and write 3 times, and it's 5 times 5, which is going to be 5 squared. Now be careful to make sure that you've got the times there, and don't actually do 3 times 5 squared, because the answer just will give you 75. Okay, whenever you add, times, take away, divide mixed numbers, you always make them top heavy or improper. So you do that by times the big number by the bottom and then adding it to the top. So we're going to do that. 2 times 5 is 10, add to the top 13. Keep the bottom the same. And 1 times 2 is 2, add to the top is 3. Now we're going to do KFC. Now KFC stands for keep, flip, change. We're going to keep the first fraction the same. We're going to flip the second fraction. And we're going to change the divide. So we're keeping the first fraction the same. We're going to change the middle to a times, and we're going to flip the second fraction. And then all we need to do is times it out, so that would be 26 over 15. Now I know 1 whole 15 can be taken off 26, and that leaves 11 at the top. So it would be 1 and 11/15. Okay, the way you solve these is exactly the same as way you solve an equation. It's just you've got an inequality sign here. So we're going to put our lines in, probably way too long. and we're going to try and get x on its own. So the first thing we're going to do is take away 10 from both sides. So we've got 7x, and then this time don't forget, don't put an equal sign, you must do this inequality sign, and 77, and then we're going to divide 7 both sides. So we've got x is greater than or equal to 11. Now it's really tempting, and there we go, I've already made a mistake. It's really tempting to put an equal sign in there, but there have been in some exams in the past that you get 0 marks, even if it's a 3-mark question, for putting an equal sign, so remember to put the same sign. Okay, so this question looks a little bit complicated, in fact very complicated, but whenever you have this type of question where you've got different categories of people or items, the best method and the clearest method is to draw a quick two-way table, which I'm going to do now. So I'm going to draw a quick two-way table, and the options for the people are either they are male or they are female. We'll add a total column or a total row, and they either do maths, English, science, and again I'll add a total as well. Okay, so I can add some lines in as well. In fact, let's do a different colour to make it a bit clearer. Okay, the absolute total is 123. Okay, and we just go through it and fill in the bits we do know. So 57 of the students are female, so 57 females. 15 of the 36 students who went to English were male, so there's 36 students who went to English, and 15 of them were male. 33 students went to science, and 29 males went to maths. So 29 males went to maths. Okay, what we asked for, so we're looking for the females who went to science. So if I highlight that, so females who went to science. So we're looking for this one here. Okay, so what you can do with this question is just try and fill out the bits that you can, right? So I'm going to start off with this top one here. Okay, and there's different ways of doing this. Now, if there's 123 students in total and 57 of them are female, then 66 of them will be male. Okay, because these two here have to add up to 123. Then if there's 66 males in total and 29 of them went to maths and 15 of them went to English, then that leaves 22 who went to science. And if there's 22 males who went to science and there's 33 people in total who went to science, then there's going to be 11 females who went to science. Now there's different ways of doing this question, and actually you didn't need to do a two-way table for this question. It's just a lot easier to check your answer, and I find it a lot quicker. So if you have this type of question, a two-way table is probably the way to go. Okay, so we've got quite a lot going on with this question. We've got 3 planks of wood attached by glues and nails, or glue and nails, so we don't need to worry about the joins. But we're looking at the 3 planks of wood. Now, we've got 2 of the lengths. One is 6 metres and the other's 8 metres. But we need to find, obviously, the third length here to be able to continue with this question. So, given the fact it's a right angle triangle, and we know 2 of the length, and we're finding a third length, it's going to be Pythagoras. And Pythagoras says that a squared plus b squared equals c squared. Now c is the one that has to be the hypotenuse, and to find the hypotenuse we just go opposite the right angle. So we're finding c. A and b don't matter which way round we do it, so I'm going to do 6 squared plus 8 squared equals c squared. And I can put my lines down as I normally do. So I always put the lines down that equals. I've just missed that one. So 6 squared is 36, 8 squared is 64, which equals c squared. 36 plus 64 is 100, equals c squared. What I'm going to do is just square root both sides. So c will equal 10. Now, when you square it, you get a negative as well, but since it's a length, it can't be negative, so it's just going to be 10. So c is 10, so we know that that's going to be 10 meters. And it says it takes 90 milliliters of paint per meter of wood to cover it. So what we're going to have to do is work out how much wood we have. So I'm going to say to the examiner wood length or something. Always try and describe to the examiner what you're doing. So we're going to do 6 plus 8 plus 10. So 6 plus 8 is 14, plus 10 is 24. Okay. And then to work out the amount of paint required, so paint required, I need to do 24, because we've got 24 meters of paint, times 90, because it's 90 milliliters per meter. So we can do this with the grid or column method. Doesn't really matter which one. I'll do the column, why not? So 0 for the first one, and then we're going to do 90 times 4, so we need to add a 0. 9 times 4 is 36. 9 times 2 is 18, plus the 3 is 21. And what we could have done is 9 times 24 and just added a 0 onto the end of it. There's loads of different ways of doing these things. So it would be 2,160 milliliters. If you ask this in liters it would be 2.160 liters, because there's 1,000 milliliters in a liter. Okay, so this is quite a complicated question because there's two ratios and they're talking about slightly different things. We're also given an amount of one of the sides of the ratio, or one of the sides of one of the ratios, and we're asked for the amount of the first side of the ratio. So it's all a little bit complicated, but the way I'd like to start these things off is by just writing down what I know from the question. So we've got football, rugby, and we've got tennis. So football to rugby is 4:3, and rugby to tennis is 6:13. So these two ratios here are kind of incompatible at the moment. Got this one here, which is linking the football and the rugby, and we've got this one here which is linking the rugby and the tennis. What I'd like to be able to do is kind of like put the two together and make just one ratio. So if you notice from the one I've put around a blue square or blue rectangle around, we've got the rugby as 3 parts of that, but in the green one the rugby is 6 parts of that. So what if I times both of these by 2? If I times both of them by 2, I get 8 to 6, and that actually matches the other ratio. So what I can then do, because it's the same parts of rugby, I can then say that it's 13 parts tennis. Okay, so all I'm interested in here is matching these two up to make these both the same. So I times the one in blue by 2 and it made it exactly the same. Now it says that 39 students picked tennis, so I need to find some way of getting the tennis to be 39. Well, that's going to be just simply timesing it by 3. And if I times that one by 3, I've got to times this one by 3, and I've got to times this one by 3. So 6 times 3 will be 18. And 8 times 3 will be 24. So we've already answered the question, because if there's 39 tennis, there's going to be 24 football. This is not the easiest question, or ratio question out there, but if you just try and link the two ratios together, then it will start to make sense and it will start to become a lot easier. So this question is a simultaneous equations question, but it doesn't kind of look like the stereotypical simultaneous equation question, because we're given a context for this. However, if you imagine S represents the price of the gumbo sweets and C represents the price of the raspberry chocolates, what we can do is we can write these two pieces of information as this. So 2 lots of the S plus 5 lots of the C equals, and I'm just going to leave it in pence rather than pounds. I find pence a lot easier to work with. And then we can write the second one as 4 lots of the sweets plus 3 lots of the chocolates equals 220. So to do simultaneous equations, you need one of the coefficients to be the same. Looking at the S and the C, to get the C's the same, I'd need to times the top, all the numbers at the top by 3 and all the numbers on the bottom by 5 to get them both to 15. But if I look at the S, that's 2 and that's 4, so all I need to do is times everything in this first one by 2, and it would get these S's the same. So I'm going to times 5C by 2, and I'm going to times the 180 by 2, which would be 360. So to get rid of the S here, so I'm just going to try and make this a bit clearer about where we're looking now. So we're looking, I might do a little bit further up, we're looking at this part here. Now to make things a little bit clearer, when I subtract, which I'm going to do to get rid of the 4 S's, we're going to have a bit of a problem because everything's going to be negative. So sometimes it's a good idea just to copy down the first equation again. So 4s plus, which is technically the second equation again. Oh, let me just rub that out. There we go. So 220. So I'm just copying it again so that when I subtract, which I will do, it can just make it a bit, well, make them positive, so make it a bit easier. Now at this stage we work downwards. So we're working downwards, we're looking at these two, and these two. And with simultaneous equations you're always working downwards. Now we need to get rid of the 4s, and that's the whole point of doing this with simultaneous equations. And there's a little rule that if the coefficients are positive, so they're both the same, or both of them are negative, so they're both the same means subtract. So just remember that, same coefficient, same sign, subtract. If the signs are different, so one's positive, one's negative, if they're different, the D in different is the D in add. So if they're different, you'd add them. But these are both the same, as we can see. So we're going to subtract them. So we're going to subtract all of these 3. So 4s take away 4s is nothing, which is great. We wanted to get rid of those. 10c take away 3c is 7c. And 360 take away 220 is going to be 140. So I'm going to get my lines in now so I can solve this. And to get rid of this times 7 here, we're going to divide both sides by 7. So we've got c equals, and 14 divided by 7 is 2, so 140 divided by 7 is going to be 20. So c, the raspberry chocolate, is going to be 20 pence or 0.20 pounds. Okay, but we need to work out what the price of the gumbo sweets are going to be. So what we do is we pick one of the original equations, and I'm trying to think what's going to be easiest. I like this one. So we're going to rewrite this, but instead of c, we're going to substitute in the 20. So it's going to be 2s, which we still don't know what s is, plus 5 times 20, which is 100, equals 180. Get my lines in. Okay, so first of all we're going to get rid of that 100, so we're going to take away 100 both sides. So 2s equals 80, and then that's a times 2 there, so we've got to divide by 2 both sides. So s equals 80 divided by 2, which is 40. And so once it in pounds, that's going to be 0.40 pounds. Now you can check this by putting both of these numbers into the second equation and check that it works. So 4 times s, which would be 4 times 4, £1.60, plus 3 times c, which is going to be 60p. Add the two together and you get £2.20. Okay, so here we've got a box plot, and it's important to understand the parts of a box plot. There are always 5 parts. We've got the lowest value, which is the start of the box plot. we've got the lower quartile, which is the start of the box. We've got the median, which is, if I can line it up right, which is the line in the box. Then we've got the upper quartile, which is the end of the box. And then we've got the highest value, which is the end. So when it asks us for the median is halfway between 10 and 12, which will be 11. And it will ask us for the interquartile range. Interquartile range, AQR for short, is the upper quartile, take away the lower quartile. So the upper quartile here is 18, and we're going to take away the lower quartile, which is halfway between 2 and 4, which will be 3. So it's 18 take away 3, which is 15. Okay, now next it says that the table shows results of cats. I think the first one was dogs. And compare the two distributions. Okay, you must always compare the medians. So looking at my dogs, or looking at my answer to the dogs, it was 11, and the median here is 15. So you need to write a sentence saying that the median for cats, which was 15, is higher than dogs, which is 11. So always state the values. Now you can also say on average they're higher because the median is 15 for the cats and only 11 for the dogs. As long as you're comparing the medians and saying which one's higher, or maybe they're the same. Okay, the interquartile range for the cats is 23 and for the dogs is 15, and the next thing you need to compare is a range. Now you could pick the overall range, or it's probably easier just using the interquartile range, and I've just done that wrong because the interquartile range for the cats obviously would be 23 take away 10, which is 13. That's very different, right? So for the cats it's 13, for the dogs it's 15. Now 13 and 15 are not that far away, so you might say they are more or less the same, or you might say that the interquartile range is higher for the dogs. As long as you back it up with the numbers and say something that makes sense, then that's absolutely fine. The way of starting this sentence, so I said on average is kind of the way to start when you the sentence when you're comparing medians. For this one you just say the spread of data for dogs is slightly higher than with cats. And then you'd say, since IQR, interquartile range for dogs, is 15 and for cats is 13. So whenever you're comparing the medians, you really should start with on average and then say the medians and write a comparative comment, and always start the sentence when you're comparing a range or an interquartile range with the spread of the data. And it just makes you makes the examiner realise that you know what you're talking about. Always include the numbers as well, and that's really important on some of the papers that you're referring to something. The first comparison is always the average, so the median, when you're comparing boxplots or cumulative frequency graphs, and the second one is always the range, and that's really important to remember. The easiest way of approaching this question is to understand what multipliers are. Multipliers, you always start off with 100%. You work out what's happening, so let's say we're adding 40%, and then you work out the final percentage, which is 140%. The final thing you do is just convert it to a decimal, so divide by 100 to make it 1.4. That means you can multiply any number by 1.4 and it will go up by 40%. So in this question it says we have Billy, we have James, and we have Sam. And we're told that James collects 40% more sand than Billy. So he's got 40% more. we're told that Sam collects 20% more sand than James. So he's got 20% more. By what percentage has Sam got greater than Billy? Okay, now the obvious answer is 60, and if you write 60, unfortunately you're not going to get the right answer. The way of doing this, as I said, is to understand multipliers. So, we imagine Billy starts off with 100%, and he's gone up by 40%. So that means he's now got, or James has 140% of what Billy has. Now, as a multiplier, that's going to be 1.4. So whatever amount Billy has, we're going to times that by 1.4 to get James's amount. Then, James then has the 100%. We add 20% on to work out what Sam has, which is 120% of what James has. As a multiplier, that's going to be 1.2. So we're going to times James's amount by 1.2 to work out Sam's amount. Now the problem is we don't know what the amount is, but we do know what we're going to do to it. We're going to times 1.4, then times 1.2. So if we get our calculator, or if it's a non-calculator paper, then you have to do this the long way. And I type in 1.4 times 1.2. And that will tell me in total what I'm timesing Billy's by to get straight to Sam's. Like so. The answer to that is 1.68. Now that's as a decimal. If I convert that back into a percentage, that means Sam, if Billy has 100%, that means Sam has 168%. So therefore, Sam has 68% more than Billy. Now, if you're adamant the answer is 60, you need to go through this, because this is why this is such a high topic, is understanding that actually it's not going to be. And the government, with all their statistics, all the time use this, and people think, oh, it's 60%. It's not, it's 68% for this question. Now there are two things you always want to try and get rid of when you're rearranging equations or formulas. The first thing is fractions. So this fraction here we want to get rid of, and we do that by timesing both sides by y minus 5. So I'm going to write out the equation again just to make it a bit bigger. And we can imagine that there's brackets around the top and bottom of this. And that sometimes helps us to answer the question. I'm going to put my lines down. So the first thing I want to do is times both sides by that y minus 5. And you must do that. You can't access the numerator of the fraction otherwise. So this ends up with being x brackets y minus 5. And on the right hand side it's just the same numerator but without the denominator. Now I said there were two things you've got to get rid of. The first one's fractions, the second one is brackets. You've got to break them open. So we're going to times out these brackets. So we're going to have xy minus 5x. And the right hand side hasn't changed at all, it's just 10 minus 3y because we haven't done anything to both sides. So what I want to do is try and get all of the y terms to the left hand side, and all of the other terms, so the x terms, the number terms, whatever, on the right hand side. So I'm going to add 5x to both sides, but I'm also going to take away, add 3y to both sides as well. So I'm doing 2 in 1 here. So it's xy plus 3y. And on the right hand side we've got that 10 that hasn't moved plus 5x. Okay, when we have this situation where we've got the brackets gone away and everything is, all the y's on the left hand side, and y is what we're looking to do it in terms of, what we want to do is factorize it, so we've just got a single y. So y on the outside, x plus 3. Now I know I said I wanted to get rid of the brackets, but we need the brackets here to be able to get y on its own. And the last step here is we just divide both sides by the x plus 3, so we get y on its own. So we get y equals 10 plus 5x over x plus 3. So let's put that into our answer box. Now it can be either way around here, it could be 5x plus 10, that's absolutely fine, still the right answer, over x plus 3. Now there's multiple ways of doing this question, there's loads of strategies out there. I'm just going to show you the method I do. I get the coefficient of the x squared, or in this case y squared, and times it by the number at the end. So that's going to give me 24. I then write down the factor pairs of that, which is going to be quite a few. There's 3 and 8, 4 and 6. And work out which of those adds together to make the coefficient of the y. So which of those adds together to make 11? Well, it's these ones, add together to make 11. I then rewrite it, but instead of that plus 11y, I'm going to write plus 3y plus 8y plus 12. So I haven't changed it, I've just split it up into 3y and 8y. Next, I'm just interested in factorising this bit, and then I'm just interested in factorising this bit. So I'm going to factorise the left hand side. Well, there's only a y that I can divide out of both of those, so it'd be 2y plus 3. And here there's going to be 4, so 2y plus 3. Now if you've done this correct, the two brackets here and here should be the same, and you should end up with a letter and a number there. Now the blue ones go together to form a bracket, so y plus 4. And that other bracket that we underlined in green, we just write that once. So our answer to this question is y plus 4, 2y plus 3, and you can write it in any order. Now there's loads of different methods of doing this. This by far for me I've found is the easiest to explain and the easiest to do. But if you have a different method, some people do trial and improvement, just keep trying different numbers. It depends on how easy the quadratic is. When you have the coefficient of the x squared being a non-prime number, that can get quite complicated quite quickly. Okay, so this is an inverse proportion question. So the first bit I start with for this question is this line here. So as soon as I see that, I just write down b, and this fish symbol, which means is proportional to. The inverse is 1 over, so whenever it says inversely proportional or varies inversely, it's 1 over, and it says the square of a, so I'm just going to write a squared. Now I'm going to get my lines in. Okay, so to get that fish sign to an equal sign, I need to times the right hand side by k, so it becomes k over a squared. Now I'm going to pick a value of a and b. Now a and b are called variables, they're going to change. The k though is a constant. When we find k once, we found k for good. Now looking at these options, I kind of like this one the best. It's kind of simple. I like a nice simple fraction, 1/8 and 8. Okay, I can work with that. So it says b is 1/8, so I'm going to substitute in b is 1/8. And k we are trying to find out, and it says a squared, so it would be 8 squared, which would be 64. So I'm going to times both sides by 64, so I can find what k is. So it becomes 64 over 8 equals k, so therefore k is equal to 64 divided by 8, which is just 8. So putting that back into this equation here, or formula here, becomes this equation here. So b equals 8 over a squared. Okay, I'm going to use that to find out what a is when b is 2. So I'm going to write the same thing as I've written down for my answer here, but instead of b, I'm just going to write 2. So 2 equals 8 over a squared. Get my lines down. Okay, so the first thing I'm going to do is times both sides by a squared. So the best thing to do is get rid of any brackets or fractions. And since that means divide, over means divide by a squared, I'm going to times by a squared, so it would be 2a squared equals 8. Then I'm going to divide by 2 both sides, so I get the a squared in its own. So it's a squared equals 8 divided by 2 is 4. Then I'm going to square root both sides. So this could be 2 or minus 2, but it does say positive value, so a equals 2. So if I put a as 2 into the answer to question A, it would be 8 over 2 squared, which is 4, so 8 over 4, which is 2, so b equals 2. Okay, so a circle theorem question. With these questions, it's really important that you set all your working out and you give reasons for every step. So I'm going to do it one way, and there probably are slightly different ways of doing it. And as long as you give the reason, then that's absolutely fine. We're asked to find ODF, and just to help us, I'm just going to mark that on. So it's that angle there. Now, just finding this angle here, which we're going to start off with, it doesn't mean that it's the same angle as that. You can't guarantee that the arrow is going to be symmetrical. So we're going to start off with this one. But how do I show the examiner that's the one I'm starting off with? Well, the letters are there so you can actually write down what you're trying to find. So I'm looking for angle OBC. And you could write the word angle or angle OBC, or you can just do a little angle on top of the B. And we know that that's going to be 90 take away 51. And the reason is that angle between tangent and radius is 90 degrees, and that's one of the circle theorems. So AC is a tangent, and OB, because O is the centre, is a radius. So the whole thing's going to be 90. So when I do that, so I'm going to do 90 take away 51, which is 39 degrees. So we know that that's 39 degrees. And it's absolutely okay to mark it on the diagram as well. And actually sometimes, not often, but sometimes the examiner will look at the diagram and might give you some extra marks because you didn't show the working out. But most of the marks for these types of questions are for the reasons, and you can't really show reasons on the diagram in a way that the examiner is going to be able to see it. So I also know, let's have a look what else I can work out. Well, that's also 90 degrees and that's also 90 degrees. And ADOB is a quadrilateral. So we can work out which angle we're going to pick next. Well, let's pick this angle here next. So what's that? DOB. So angle DOB is going to equal 360 take away 30 plus 90 plus 90. Okay, so I need to give a reason. Well, let's work it out first, and we can give a reason afterwards. So we're going to take away, what is it, 880 plus 30, so that's 210 from 360. That's going to be 150 degrees. And the reason is angles in quadrilateral. And we should really say that the angle ABO and ADO are angles between a tangent and radius as well, but I'm not going to. We've already used that reason, and it's clear in our diagram that we've just repeated the same reason. Okay, so angle DOB we've got as 150. So let's mark that on our diagram. So we can work out this angle here. Okay. And it's very difficult to know what to call this angle because we've already called DOB once. So we could call this other DOB. Let's go for that. Other DOB. equals 360 minus 150. Okay, and the reason for that is just angles on a point. So that's 210 degrees, angles on a point. Okay, so what are we up to next? Well, we can work out this angle here, and actually let's mark on the 210 as well. So we've got it all on our diagram. We can work out angle DFB. So DFB, and this time we're using the circle theorem that says angle at the centre, which is the 150, is twice the angle at the circumference. So angle at the centre is twice the angle at the circumference, so it's going to be 150 divided by 2, which is 75 degrees. So angle at centre twice angle at circumference. Now, if your teacher's given you different ways of writing the circle theorems down, that's absolutely fine. There is no strict way of writing it down. So that's going to be 75 degrees. And if you look, we've got the arrowhead BFDO, which is a quadrilateral, and we've got 3 of the lengths. So we can work out ODF. I'm going to have to scroll up because my memory is not that good. So we're going to take them all away from 360. And what is it? 210, 75 and 39. Okay, so we're just going to take those away from 360. And obviously if you're doing this in the calculator paper, then please feel free to use a calculator. And we get 36 degrees. And again, it's just angles in quadrilateral. As a rule of thumb, my experience with these questions is they're normally looking for between 2 and 3 reasons. Obviously on this question there's an awful lot of reasons, but if you walk out of the exam and you just think, oh hang on, I only wrote down 3 and actually there's a 4th, sometimes you'll get the full marks, so don't panic too much. Just when you're doing the question, try and write down as many reasons as you can. Even really obvious ones like angles on a straight line or angles in a quadrilateral will help you get the marks. Normally, again, for circle theorem ones, they're looking for circle theorems as well as those ones. First thing I do with this question is just write the numbers out. They're a bit small in the question. Now with all sequences we're interested in what it goes up in. So we're interested in what these go up in. So if you've got a calculator you can just do 25 take away 13. If it's on the non-calculator paper then you can just quickly do it in your head. And I'm going to do this for a few of them. Now you might notice straight away that the next one goes up in 18. Well, let's have a look at the next one. That goes up in 24. And the last one goes up in 30, which is what we'd expect. So they're not going up by the same amount. Now when they don't go up by the same amount, we need to have a look at the second difference. If they don't go up by the same amount in the first difference, that means it's not going to be an arithmetic sequence. We're not going to use the standard linear nth term, the one that you're probably used to. For a second difference, it's going to be a quadratic. Let's check to see if there's a second difference. So that's add 6, this is add 6, and this is add 6. So we know it's a quadratic sequence, so it's going to involve an n squared somewhere. Right, the step that people have difficulty with is you get the second difference and you halve it. And that's all you've got to do. Now, that halving, the dividing by 2, won't ever change. You'll always halve it, and you get the number 3. This 3 is going to be the coefficient of the n squared. So I can fill that into my answer now. Now, the problem is we don't know what else we need. What we need to do is write out the sequence 3n squared. So let's number the terms. So we've got the first term, second term, third term, fourth term, and fifth term. And so we've got our sequence, which is, I'm just going to copy this out again, 13, oh, all right, 35, it's 25, 43, 67, and 97. And we're going to write out the 3n squared, which we've just discovered. Now, that means we just square the sequence number and then times by 3. So 1 squared is 1, times 3 is 3. 2 squared is 4, times 3 is 12. 3 squared is 9, times 3 is 27. 4 squared is 16, and times that by 3 is going to be 48. 5 squared is 25, times 3 is 75. Now what I want to do next is I want to subtract them. I want to subtract the sequence. I want to do the sequence take away the 3n squared. We know that 3n squared is a part of it. We need to just take it away so we know what's left. So 13 take away 3 is 10. 25 take away 12 is going to be 13. 43 take away 27 is going to be 16. 67 take away 46 is going to be 19. And 97 take away 75 is going to be 22. Okay, now we end up with a little sequence here. Okay, we've got 10, 13, 26, 10, 13, 16, 19, 22. Now we find the difference in that. So that's a plus 3, plus 3, plus 3, plus 3. Now that's a linear sequence. Now we've got to find the nth term of it. So to do that, we find the 0th term. So we go back 1, we subtract 3. And that tells me, so I'll say linear. So that's going to be a 7. So we know we're going to add 7. And we know it goes up in 3, so it's going to be 3n plus 7. So we got our 3n squared already, and we just need to add 3n plus 7. So the first thing you need to do is find out what the quadratic sequence is, the quadratic bit of it, the squared bit. Then you've got to find out what the linear bit of it is, and then just add them together. Okay, so the first thing to do in this question is notice that we've got a bracket squared and another bracket squared. So the first thing to do is you need to write those brackets twice. If you don't do that, you end up squaring the 3 and squaring the root 2 and then thinking that you're going to get the right answer. Unfortunately, you can't get the right answer with just squaring the two of them because they are quadratics. So I'm going to write them out as 2 brackets because anything squared is itself times itself. Okay, now we're going to expand these. Now I'm not going to go into the methods of expanding quadratics, but we've got loads of videos on our channel, on our website to help you with that. So use whatever method you are comfortable with, whether it's FOIL or smiley face or whatever you want. I'm going to put them into brackets though. So 3 times 3 is 9. Then we've got plus 3 root 2 plus 3 root 2, so plus 6 root 2. And then we've got root 2 times root 2, which is plus 2. Okay, so second one, 3 times 3 is 9. And we've got minus 3 root 2 minus 3 root 2, which is minus 6 root 2. And then we've got minus root 2 times minus root 2. 2 minuses make a plus. And root 2 times root 2 is root 2. Now, the reason I kept them in brackets is because this is really important. There's a -1 there, and it means we've got to multiply everything in the second bracket by -1. So the first bracket's unaffected, so we're just going to get rid of the brackets there. Don't need to worry about that. But the second bracket, I need to times everything by -1. So that first one is -9. The second one is, well, minus times a minus is a positive 6 root 2. And then a minus times a positive is a minus, so -2. That means that we can cancel out the 9's there. We can cancel out the 2's there. And all we're really collecting here are the roots. So 6 root 2 plus 6 root 2 is 12 root 2. Now it says it wants it in the form a root b. So a is the number outside the surd, which is 12, and b is the number inside the surd, which is 2. There are a few different methods to answer this question, but I prefer the method where we just replace f of x with y because it becomes a lot easier. So I'm just going to write out the same equation. Now, when you want to find the inverse, which this is, of the function, all you do is swap the y and the x around. So we're going to have x equals 4y minus 10 over 7. And then all we need to do is get it, so we've got y equals. So the first thing I'm going to do is times both sides by 7 to get rid of the fraction. So we've got 7x equals 4y minus 10. Then I'm going to add 10 both sides. So we've got 7x plus 10 equals 4y. And then I'm going to divide both sides by 4. So I've got 7x plus 10, all of that over 4, equals y. Now, it's not y really, it's f, inverse of function, x equals 7x plus 10 over 4. And the 7x and the plus 10 can be either way around. So 7x plus 10 over 4. Okay, so we've got a recurring decimal, but we have an annoying 0 there. So what I'm going to do is I'm going to answer the question, convert this into a fraction, and I'm just going to worry about that 0 later on. So we're going to call x 0.9898 recurring, and so therefore 100x would be 98.9898 recurring. So 99x, by taking away these two, would be 98, and then these will cancel. And then let's put my lines in. So divide both sides by 99. You get x equals 98 over 99. Now we know to get from 0.98 recurring to 0.098 recurring, we're going to divide by 10. So we need to divide our fraction by 10. And you should know that the rules are same change flip or KFC or whatever you want to do. So you can convert that to a times by flipping the fraction. And so 98 times 1 at the top is 98, and 99 times 10 at the bottom is 990. Now there's something else I can do. I can cancel this down, so I can halve top and bottom, so 495 at the bottom, and half of that is going to be 49. Now 49 has 1, 49 and 7 as factors, and I don't believe 7 goes into 495. For the cancelling of this, they're not normally that devious, and it will either be dividing top and bottom by 10 or dividing top and bottom by 2, but just be prepared. Okay, to do this question you need to understand the sine wave. So I'm going to draw the sine wave for this, and it's going to go to 1 here, and then down to 0, and then down to 1 here, back up to 0. Okay, so it says draw the graph y equals sine 2x. So figure out what's happening here. So I'm going to pick this point here. So I want to know what the y is at 90. So the first thing I'm going to do is double 90, and it's going to be 180. Then I'm going to sine it. When I do that, I get the answer 0. So it's actually 0. Now it thinks I'm up here at 180. Now at 180, I'm going to double that before I put it into my calculator, and it thinks I'm going to be at 360. So it's going to be at 0. So what's going to end up happening, and the black one is my answer, is the actual graph will end up being condensed like so. Oh, I haven't gone far enough down. That's rubbish. I'm really not good at drawing these. Like so. So instead of just one completion of a wave, you get two completions of a wave. And if I tidy this up a little bit. So a 2 will condense the graph. So it will mean that it goes through double the amount of cycles. If you had half x, then it would stretch it out, so it only does half the cycles. Okay, so this looks like quite a complicated question. The important part of this question actually is this bit here. Now this looks like it's trying to give you a little bit of help. Actually it gives you a huge amount of help. It's basically telling you that when you add them together, the common denominator will just be a quadratic. Now it might be tempting just to multiply all of this by all of this and kind of get a cubic equation, but actually the answer is saying no, don't do that. The bottom will work if you factorize it. So what we need to do is factorize the one on the right, and hopefully we'll notice something about it. So we've got videos on how to factorize quadratics where a is more than 1. And it's quite a unique method, but I'm going to go through it quickly, but please use the videos for a kind of slower explanation. So what I do is I times together the first and last ones, times them together, and that gives me 48. And then I've got to find a factor pair of 48 that adds together to make the coefficient of the x. So 2 and 24 won't work. 3 and 16. So then I rewrite the 19x as 16 and 3. 3 and 16 doesn't matter. You get the same answer eventually either way. Then I just look at these two and factorize them linearly, and I just factorize those two linearly. So 8x squared plus 16x, so I can divide out an 8x. And 3x plus 6x I can divide out of 3. And you notice that the bracket here is the same. Then you pair up the bracket that's the same with the bits on the outside. So you get 8x plus 3 and x plus 2. Cool. So I can rewrite that. Now I'm going to rewrite the question. So now it becomes 1 over 8x plus 3 x plus 2 plus 1 over x plus 2. Now you notice that actually that bracket is the same, so all I need to do is times top and bottom here by 8x plus 3. I'm squishing it a little bit, and it will have common denominator. Right, so I'll rewrite that just to make sure my working out is really clear. So the top becomes 8x plus 3, and the bottom actually is the same as the other side, which is good because now we can add the tops together. So if we add the 1 to the 8x plus 3, we get 8x plus 4. And then we've got 8x plus 3, and then x plus 2. And that's my answer. Okay, so there's a lot going on with this question, and there's a lot of areas of maths that this question is involving, so we need to be quite good kind of across the board with our knowledge of the different areas of maths. The first thing to notice is we've got the equation of a circle. Now, important thing to highlight with this, and we'll do a little diagram up here. Because it's y squared plus x squared equals a number, we know the centre of the circle is going to be at 0, 0. So the circle looks something like this. I am not good at drawing circles, actually that's not too bad. And that can help us, or that will help us later on. So we know that, first of all, well, having a look at this question, so we've got a point T, which I'm going to put here, so point T, and it's on the circle. Now, we're looking for the equation of the tangent, so if I draw the tangent on, probably not going to be as good as my circle. We're looking for this equation here. But something that will help us is to understand that a tangent and a radius hit each other at 90 degrees. So if I draw on the radius, which we know starts at the centre, we know that that bit there is going to be 90 degrees. So first thing we're going to do is work out the gradient of, we'll call this M1, the gradient of this radius. Then we're going to find out, because we know that, we're going to find out what the gradient of this second line is, and then we're going to find out what C is, so we can actually find out the equation of the line, because it will be y equals mx plus c. The only thing we've got left is c to work out if we've already got the gradient. So a lot going on there. We're also told the coordinates of t, but they're kind of in a not very helpful form. They've got surds and they're in fractions, so it's not the most helpful piece of information that we can have. So I'm going to work out M1 first, which is the gradient of our radius. So I'd probably show the examiner that I'm working out the gradient of the radius. So to find out the gradient, we do change in y over change in x. Now over just means divide. Now because we know that 0, 0 is on the radius, all we can do is do the y coordinates given to us here, take away 0, and then put that over the x coordinate, take away 0. So it's just going to be 5 root 17 over 3. Over means divide, so I'm going to show it as a divide sign, and then 10 over 3. So another area of maths we need to know is KFC, or same change flip, that whenever we're dividing with fractions, we keep the first one the same, we change the divide to a times, we flip the second one. Now we can times them, so 3 times 5 is 15, so it'd be 15 root 17 over 3 times 10, which is 30. And if you look at the 15 and 30 cancel to make that just 2, so root 17 over 2. So M1 is root 17 over 2. Cool, right. Now we're going to work out the tangent. I'm going to do this one in black because green's not the nicest thing to write in. So I'm going to start working out M2, which is our gradient that we actually want. And to do this, we know that the M1 and M2 are going to be perpendicular because they touch each other at 90 degrees because of circle theorems. The angle between a tangent and radius is 90 degrees. Therefore, we know that they'll multiply together to make -1. So basically, to get from one to the other, you find the reciprocal and you change the sign. So we've got root 17 over 2, so that's a positive number, so it's going to be negative. And we're going to flip that, so it becomes 2 over root 17. Cool, we've got our gradient. So we're going to do y equals mx plus c. Now we know a y coordinate, which will be 5 root 17 over 3. because that's both on the radius and the tangent. So we know what the m is, which will be minus 2 over root 17, and that's going to be times by the x. So I put the x up there, plus c. So I'm going to put my lines in. I'm going to give myself a little bit more room here, because I think it's quite easy to get congested. So let me add my straight lines down. Okay, so first thing I'm going to do is add the entirety of minus 2x over root 17 both sides. So it would become 5 root 17 over 3. I'm just going to add that 2x over root 17. Now, let's get rid of that. Equals c. Now I left that x in just so that we could give ourselves a bit of room, so I could show you a little bit easier what's happening. But I'm going to substitute that x in, and so that x is 10 over 3. So it'd be 5 root 17 over 3 plus 2 over root 17 times, and let me just get that x coordinate, 10 over 3 equals c. So I'm just going to sort that bit out. So 2 times 10 is 20, and then be just 3 root 17. Okay, let's extend these lines a little bit. Okay, so now we've got a problem here because we're adding two fractions but they don't have the same denominator. But if I times both the top and bottom of the left hand fraction by root 17, they will have the same denominator. So I'm going to do that now. So I'm going to do 5 root 17 times root 17. Now when you do a root by itself, when you times a root by itself or a surd by itself, it just gets rid of the square root. So we're going to end up with 5 times 17 at the top, which would be 85. And at the bottom we'll just have 3 root 17 plus 20 over 3 root 17. So all I've done there is times the left-hand fraction, top and bottom, by root 17, which is odd because you normally go the other way with it, but well, I suppose I could have rationalised the right-hand side. Doesn't matter too much for this question. Okay, so now I can add the tops. So it would be 105 over 3 root 17 is equal to c. Now 105, if you add up the digits, 1 plus 0 plus 5, it equals 6. And if that number, when you add up the digits, is divisible by 3, then the whole number is divisible by 3. My knowledge of my 35 times table is good enough to know that I know that 105 divided by 3 is 35. So that would be 35 there, and that would just be root 17. So c is 35 over root 17. Took us a while, but we got there. Okay, so looking back at my y equals mx plus c, we know what m is now. So we've got y equals, and it's minus 2 over root 17 x, and we're doing plus 35 over root 17. Now if you look at the question, it says it wants it in a slightly different way. It wants the root next to the y, it wants a number, and then minus whatever the x bit is. So we're not quite finished yet, but we're just needing to tidy this up a little bit. And what this is suggesting that we do is times everything by root 17. So we times everything by root 17. Don't forget that you've got to times each term, so that's all 3 terms. So here we've got y root 17 equals minus 2x, because it's got rid of that over root 17, plus 35. And it wanted it swapped around, so we'll just tidy that up. So it's 35 minus 2x. So looking back at the question, a will be what's in the root, which will be 17. C will be the number on its own, so C, which is 35. And the b will be the coefficient of the x. Now, but technically, because it's got a minus in there, b is 2. But in the exam, I can imagine that if you wrote minus 2, it depends really. mean, technically B should be positive 2 because it has a minus in this bit here. Well, I hope you enjoyed that video. Please go to onmaths.com and have a look at what we've got. Try this paper out on there, and I'm sure there's a link that comes up there. Also, if you disagree with anything that I've said in the video, or you've got different alternative methods, please feel free to comment below. I will be keeping an eye on the comments, and no one is perfect, so I will be putting any revisions in the description below. Hopefully there's none this year, but there's always a few that slip past the net. If you've enjoyed this video, please click like, and also please click subscribe to keep up to date with our future content. Thank you very much.